Hello everyone, welcome back to MrMiers Math Channel. Today we're going to introduce a new chapter, which is Chapter 10, which talks about basic statistics and probability. So today we're going to go over some measures of center and variation, including the mean, median, mode, and range of a data set. Now, understanding basic statistics and probability is essential to becoming an informed citizen, because so often there's cases from news outlets and organizations, as well as like articles on the internet and social media, where they're intentionally trying to deceive you, whether it's by presenting false information or more often presenting accurate data but in a deceiving manner. So understanding basic statistics and probability will help you not be deceived when you're looking at, these articles or a data set or something like that, when you're looking at a study. All right, so I can't stress enough the importance of understanding basic statistics and probability. All right, let's get into it. So we have three basic measures of center that we're going to talk about. So a measure of center is a measure that represents the center or typical value of a data set. Okay, when we say typical value, that might be a value that's used to describe what's normal in a data set. And oftentimes we have the mean and median, and then sometimes we also have the mode when describing what's typical in a data set. All right, so the mean of a numerical data set is the sum of the data divided by the number of data values that we have. All right, so what we would do is we'd add up all of the data values in the data set and divide by how many of those data how many data values there are in the data set. The symbol X bar represents the mean, and we'll use this when we talk about the mean, and then also we'll use this when we're trying to find other statistical measures. The median of a data set is the middle number when the data values are written in order. Quite literally, it's the number that's in the middle of the data set. Think of like the median on a road. Okay, the median on a road is in the middle of the road. Same thing for the median in a data set. All right, sometimes in our data set we have odd numbers of values, and then sometimes we have even numbers of values in the total data set. When we have an odd number of values in the data set, there's going to be exactly one number that's in the middle. However, when we have an even number of values in the data set, two values are going to lie in the middle. Okay, so to find the median of a data set like that, what we would do is find the mean of the two middle values, all right, which is just the average of the two middle values. All right, and then finally the mode. The mode of the data set is the value or values that occur most often. So it's the most frequently appearing value in the data set. There may be one mode, no mode, or more than one mode. All right, so if we take a look at a data set and one value appears more frequently than any other value, that data set would have one mode. If no values appear more frequently than any other value, we'd have no mode. And then sometimes, a couple or a few values will appear the same amount and more frequently than any other value in the data set. And in those cases, we would have more than one mode. Okay, so let's get to our first example. In example 1, an amusement park hires students for the summer. The students' hourly wages are shown in the table. All right, we want to find the mean, median, and mode of the hourly wages. So let's just do that. Let's find those basic measures of center. So to find the mean, remember, we're going to add up all these data values. If we do that, we'll get 77.2. And we're going to then divide that total by the number of data values that we had in the data set, which is 8. If we do that, we get 9.65. So 9.65 would be the mean or the average in the data set. Now to find the median, we've got to first list the data values in order. So I'm going to do that right here. I'm going to list these data values in order, and as I go, I'm going to cross them off the list. Starting with 825. Notice we have another 825. We do have to write that down because these are two different data values in our data set. Although they have the same value, this might represent one person, and that might represent another person's hourly wage. All right, so both need to be represented here. All right, then after that, we have 845, 865, 875, 910, 925, and then 1650. All right, so now what we're going to do is we're just going to go from the outsides in and find that number in the middle. All right, so I'm going to mark off one on each side, then another on each side, then another, and now we can see there's two data values in the middle. And that makes sense because there's 8 data values in total in this data set. All right, so for these two values in the middle, to find the median, we need to find the average of those two data values. Now, some of you might already know that that value that's right in between 865 and 875 is 870, but if we didn't know that, what we would do is just take 865, add 875, and divide by 2 because we have two data values that we're using. That would help us find the average or the mean. Now we're going to find the mode. All right, like we said before, the mode is the most frequently appearing number. Okay, and if we take a look at this data set here, there's two numbers that appear more frequently than any other number. All right, all the other data values appear once. 825 appears twice. So 825 is going to be the most frequently appearing number. All right, so now this is where things get interesting. These three measures of center can be used to describe what is typical or normal in a data set. So in this case, the typical hourly wage of these students at the amusement park. Most often, of these measures of center, the mean and the median is used to describe what is normal. But make sure you know which one and why, because what you're looking at might be intended to mislead you. All right, so what we're going to do is we're going to figure out what measure of center best represents the data. Now, whenever this question is asked, there can always be multiple interpretations. Now, in an example like this, it's meant for there to be one answer to this question. Okay, the data set is supposed to be skewed so that there's one data value that that best represents the data. Okay, but in most real-life examples, maybe we could use more than one measure of center to best represent the data, or more than one statistical measure to best represent the data. So let's take a look at our data set. We have our three measures of center, and any one of these could technically be used to represent the data set. But what we want to do is figure out what is normal, okay, based on our data set. Which one of these three? Now let's just start from the bottom here with the mode, 825. If we were told that the average hourly wage for these students at the amusement park is 825, would that be reasonable? And my argument would be no. Although it appears twice, there's 6 other people that make more than that amount. Okay, so if employer was hiring you to start on this job, and they told you that the typical hourly wage of a worker is $8.25, maybe they are trying to mislead you. Or maybe that is just true. Okay, maybe you just start at that amount and then you build your way up. But there's always that possibility, okay, if these people all started at the same time, okay, that person is trying to mislead you. Let's take a look at the mean or the average now. 965. Okay, let me erase this really quickly. Here we go. If the employer said, you know, an average hourly wage here is 965, okay, which would be right. That is the average. That's the mean. But once again, in terms of what is normal for this population here, only one person makes more than 965. Everybody else makes less than 965. Okay, so that's kind of misleading. I would beg to argue that the best measure of center for this data set would be the median. All right, more of the values are closer to the median than they are the other two values. Okay, so for our explanation, we could say the majority of data values are closer to the median. So that would better describe this population. Okay, I know I've talked a lot. We're going to get through these next examples and just stress the mathematics in finding like the mean, median, and mode and things like that. So let's move on. All right, so let's say, what if the park hires another student at an hourly wage of $8.45? How does this affect the mean, median, and mode? Well, one thing that we could do is we could find the new mode, median, and mean, and then we could just compare that and see what happens. So if we used 845 in the data set, and now we have 9 values, and I'm just going to write n equals 9 for the number of data values that we have in this data set. To find the new mean, we would add up all those values, and we'd get 85, 65. We'd divide that by 9, and notice it changes our mean. Our new mean is 952. If we include 845 and find our new median, we'd get 865. And then when we're finding the mode, we would actually have 825 and 845 as the most frequently appearing values. Both of these values would appear twice more often than any other value. All right, so notice it does change these values. Okay, it lowers the mean. All right, it lowered the median, and then we could say it didn't really change the mode, but we definitely did add another value in the mode. Now we're going to reassess and then once again find which measure of center best represents the data. Once again, I would argue that the median would be the best measure of center for the data set, at least more than the mean. Okay, the mean would still be a little skewed for this data set. All right, let's go on to some extra examples, some tricky examples. Okay, so the following says find the value of x. We're given this data set, so 2, 8, 9, 7, 6, and x is some other value that we don't know. But what if we knew the mean is 6? We could find that missing value. All right, we know what the mean is. The mean is just adding up these values, including that missing value of x, and dividing by how many we have. So that would be 6 values in this data set, and the mean is 6. All right, so we could just rework this equation and figure out what that missing value is. So in this case, we could always combine our like terms here, and then also if we want to get rid of this division, we could multiply by 6 on both sides. So we'd get 32 plus x equals 36. And then by subtracting 32, we would get 4. So we just found our missing value. What we really did here was we figured out if the mean is 6, what is the total, or what should the total be? We just had 6 values times the mean is 6, and we figured out that the total was 36. And then we subtracted all the values that we knew to find that missing value. Not too bad, actually. All right, if we're told that the following is the data set and that the mean is 14, remember the median is 14. Remember, the median is the value that's in the middle of the data set. So in the data set, if we list them in order, the middle value right there would be 14. All right, now there's a couple different ways that we could find that missing value. The more mathematical way would be to set up the average, or to set up the mean. To find the mean of these two values, we would add those values, divide by how many we have, and set it equal to that total. So we'd have x plus 12 divided by 2 equals 14. And now, once again, we could just rework this equation. Right? We'd multiply by 2 on both sides, and then subtract 12, and we'd get 16. All right, but that's not the only way to find that value. Another way that we could find that value is simply by seeing how many units away is 12 from the average of these two values. Right? That's 2 units away. Okay, x, whatever it is, it's got to be the same amount of units away because 14 is right in the middle of those two values. So if x is 2 units away, then we would get 16. Much simpler, a little bit easier. All right, so let's move on. An outlier is a data value that is much greater than or much less than the other values in a data set. All right, so it's the one that skews the data either to the left or to the right, or lower or higher. In this data set from example 1, the outlier here is that $16.50. All right, this value skews the data set. Okay, when we calculated the mean of the data set, okay, it drastically raised the mean. So first, here's the outlier, and then we want to talk about how does the outlier affect the mean, median, and mode. Like I said, it skews the mean. All right, how it skews the mean, we could easily find by calculating the mean without that data value. And what we would find is that that data value drastically raises the mean of this data set. All right, and what we want to do is describe one possible explanation for the outlier. Okay, there's a lot of different things that could happen. You know, this person could be a manager. You know, they put in their time. Okay, they're a good worker. They've got more experience. All those things. There might be a lot of good explanations as to why that person makes the amount that they make. And that's just fine. All right, but that does skew the data set. All right, let's move on. Now let's take a look at the following data set. This is annual salaries of employees of an auto repair shop. Right? For part A, we want to identify the outlier. So let's look at the data set and see the one that stands out. Okay, we have 32,000, 41,000, 38,000, 72,000, another 42, 38, 45, and 35. So most of these are within that 30 to 40 range. And then we have the one that really stands out, which is the 72,000. Okay, how that affects the mean, median, and mode is it's going to raise the mean. Absolutely, it's going to raise the mean. Now, it doesn't always affect the median, though. Okay, if we had two values that were the same that are in the middle, taking that value out might leave that same value. But in this case, it also raises the median. If we took that value out and found the median, we'd get something that was different. And then also, in this case, a lot of times it doesn't affect the mode, and in this case, it doesn't affect the mode. All right, the mode would be the same without that 72,000. And then once again, describe one possible explanation for the outlier. There may be many good reasons why that person makes 72,000. Okay, they could be more highly qualified or various reasons. All right, now we're going to briefly talk about finding the range and standard deviation of a data set. All right, so let's move on. All right, so measure of variation is a measure that describes the spread or distribution of the data set. One measure of variation is the range. The range of a data set is the difference of the greatest value and the least value. It is quite literally the span in the data set from least to greatest. So let's take a look at example 3. We have two reality cooking shows, each with 12 contestants. We have show A and show B. What we want to do is find the range of the ages for each show. Okay, so I'm going to use a different color for each. For show A, we want to find the youngest person, which would be the 19-year-old, and then the oldest person, and that would be the 31-year-old. So now we're going to find the range for show A, and that's just going to be 31, the greatest value, minus 19, the least value, and we would get 12. So the span in the data set would be 12 years of age. All right, now let's take a look at show B. We're going to find the range by figuring out the youngest person, which once again is 19, and then the oldest person, which here is 48. So we would do 48, the greatest value, minus 19, the smallest value, and we'd get 29. All right, so we can see that show B has a greater range between the ages of these contestants. All right, let's take a look at the next one. All right, finally, after the first week, the 25-year-old is voted off show A and the 48-year-old is voted off show B. All right, so I'm going to mark those. 25-year-old from show A, 48-year-old from show B. Now we want to calculate the new range. All right, so to find the range of show A, we have the oldest person, which is still 31, minus the youngest person, which is still 19, so that range didn't change at all. All right, and then for show B, okay, we have the oldest person now is 32 years of age, and then the youngest person is still 19. So that's 32 minus 19, which would be 13. Now the range or the span between the ages of these contestants is much closer. All right, folks, in preceding sections, we'll be getting into the weeds a little bit more here, but we're just going to keep it basic, just the things that you need to know about basic statistics and probability. All right, folks, thank you for watching. If you enjoyed this, if you found this helpful, like, subscribe, and share. Thank you, and have a great day.